guys, let's continue. Okay, let me show you what we have covered so far. We have started with the chapter redox. 3 weeks ago. Okay, redox means that you have oxidation and reduction happen at the same time. Do remember you have 4 different methods for you to judge whether a process is oxidation or reduction. Okay, so the first method is called oxygen method. The second method called oxidation number method. The third method called hydrogen method. And the last method called electron method. Correct me if I'm wrong. I think we covered all. Okay, we've covered all the 4 methods here. Okay, but I want to tell you the most important method you must know for your SPM is this oxidation number and electron method. Must know. Alright? So these 2 methods you must know in your exam. So please make sure that you really can master these 2. Okay, so for today we will go on with the second spectrum. Today we will start something with application of redox. Okay, so now we will go on with the application for redox. Redox has a few applications. The first application is called metal displacement, which we will cover in detail by today. The second one is called halide displacement, which we will cover a bit by today as well. After that, we will learn how to convert Fe2 plus to Fe3 plus and Fe3 plus back to Fe2 plus. After that, you will learn something called U-tube. Then you go for something called rusting. At the end of the day, you will go for reactivity series. So these are all the applications we need to know. There are total 6 applications out here. Right, so today we will cover 2. Okay, today we will cover 2 applications. It's not very hard, but you must make sure that you can understand all the basic things that we learned previously. Okay, all the basics that we learned previously, the 4 methods. Okay, let's start with the first thing called metal displacement. Guys, let's start anything for metal displacement. Did I talk about metal displacement last week? Not at all. You heard about, I mentioned the word gangster bully? Yes. Yes, okay, that means I started a bit lah. Okay. Alright, let's start with the first thing. Okay, let's relearn this again. Okay, we will go for something called metal displacement. Okay guys, whenever you saw the word displacement, it means that gangster bully concept. When you see the word displacement, it means gangster bully concept. What it means by gangster bully concept? A more powerful substance, a more powerful metal will go to rob the belongings of the less powerful metal. Okay? A more powerful metal will rob the belongings of the less powerful metal. Okay? So this concept called metal displacement. Okay, again guys, recall back. How on earth you know which metal is more powerful gangster, which metal is less powerful gangster? You refer to ECS. Okay? So recall back your electrochemical series here. So electrochemical series, in short form, we call it ECS. You all must know this, alright? So your ECS is this, okay? You can use your own method to memorize, it's okay. But you all must know your ECS. Okay guys, I want you all to know, the higher the metal in ECS, they are a more powerful gangster. The lower the metal in ECS, they are less powerful gangster. Okay? So this is what you need to know. Alright, let me do a quick demonstration. What is gangster bully concept, aka metal displacement? Okay? The concept is this. Everyone put your eyes on here. Let's say we have this. We have a piece of zinc. You go to react with copper sulfate. Okay? Now, how you know this is the metal displacement? You see zinc, which is a metal, you see copper, which is another metal. When 2 metals come together, you know that this is a metal displacement. I repeat, when you saw a metal go with another metal, this is a metal displacement concept. Okay, how to know whether zinc can or cannot rob the sulfate from the copper? Look at ECS. Zinc is over here, copper is over here. Zinc is higher than copper. In the other word, zinc is a more powerful gangster than the copper. So since zinc is more powerful than copper, zinc is capable to rob the SO4 away from the copper. So when zinc rob the SO4 from copper, you will get a fella called zinc sulfate. You will get zinc sulfate. Alright, so what is the formula for zinc sulfate? Zinc is Zn2 plus, sulfate is SO4, 2 minus. 2 plus 2 minus cut off ZnSO4. This is how you get the formula for zinc sulfate, okay? After that, once the sulfate robbed by the zinc, now the copper don't have sulfate anymore. Now the copper become alone. Okay, that. So this is called metal displacement. So far so good. Okay, let's try one more example. What if we have this? What if we have a piece of silver and then this fella we go for iron sulfate? Let's try this together. Okay, silver and iron. Silver is here, iron is here. Silver is lower than iron. So when silver is lower than iron, silver couldn't rob the sulfate from the iron. So in this case, what happened? Nothing. So no reaction happening. So you won't have any chemical reaction at all. Is it okay? Because silver is lower than the iron in the ECS. Silver is a weaker gangster compared to the iron. Silver is not capable to rob the sulfate away from iron. Okay? Right now, one more last example here. What if we have this? We have a sodium and then we react with, let's say, a copper sulfate. Let's try this. Sodium is somewhere here, copper is somewhere here. As you can see, sodium is higher than copper in ECS. So when sodium is higher than copper, in the other word, sodium is a more powerful gangster. So when sodium is more powerful, sodium should be capable to rob the SO4 from the copper here. The concept very easy, but a lot of us always do a simple mistake. A lot of us, we always think, oh, I think sodium can rob the sulfate. Then we just simply swap the location. We just swap. We just take Na and sticking along with SO4, and then the copper they put outside. A lot of people, they do that. A lot of people will say, oh, zinc is more powerful gangster than copper, zinc can rob the sulfate. Swap. So the SO4 go up, becomes the NSO4, then the Cu alone. They do that. This is not a good move. Why? Let me show you now. Sodium is higher than copper in ECS. That's true. Sodium can rob the sulfate from the copper. That's true. So at the end of the day, you should get a sodium sulfate. Because when sodium rob the sulfate from the copper, your final product called sodium sulfate. But the formula is what? You learn this in Form 4 Chapter 3. Form 4 Chapter 3, how you change a chemical name to formula. You must know the charge. Everyone, the charge for sodium is how much? Na plus. The charge for sulfate is what? SO4, 2 minus. Form 4 Chapter 3 taught us, when these two ions, the charge is different, what do you do? Cross. We do a cross method. So we do a cross, the one come here, the two come over here. So the formula is supposed to be Na2 SO4 1. Should be Na2. So if you just swap, there's no 2 here. That's wrong already. I feel that. Okay, so it should be Na2 SO4. So you cannot simply swap the location. Okay, so you have to predict the formula again. Let me show you one more time. By the way, balance it. Put the 2 here. Let me show you another one more example. Aluminium go to react with a furler. Let's say aluminium react with a furler. Let's say this furler called copper oxide. Just assume. Okay. Now what happens? Same thing. Aluminium and copper. Aluminium is over here though. Copper is here. Aluminium higher than copper. Okay. Aluminium is a more powerful gangster. Aluminium should be able to rob something from the copper. What is the something? Oxygen. Aluminium should be able to rob the oxygen. So if you just simply swap, you will write ALO, which is wrong. Okay? It's wrong. Cannot. So what is the proper formula? When aluminium rob the oxygen from the copper, you should get a furler called aluminium oxide. You should get aluminium oxide. What is the real formula for aluminium oxide? Aluminium, the charge is Al, 3 plus. Oxide, the charge is O, 2 minus. Form 4 Chapter 3. When these two ions, the charge is different, do a cross method. The 3 goes to the right, the 2 comes to the left. So it's Al2O3. So it's Al2O3. You see, differ so much. I give that. So you must understand that the more powerful gangster will take the belongings of the less powerful one, and you cannot simply swap the location. Okay? You have to predict the formula yourself. Okay? So now once aluminum take the oxygen, the copper now becomes alone. Cu here. That's it. Okay? So make sure you understand this. Again, of course, you have to balance it. You can balance it on your own. I do a bit faster. Oxygen got 3. Oxygen got 3. Copper got 3. Copper got 3. Aluminium got 2. Aluminium got 2. That's it. Okay? So it's not a very hard concept, but you must be very careful. Okay?
Yeah.
So guys, metal displacement means gangster bully concept. A more powerful metal can take away something from the less powerful metal. Okay? How to know which metal is a more powerful gangster? ECS. Okay? Use your ECS to predict which metal is more or less powerful. Simple as that. Okay? So this is the basics idea. This is basic idea. Now let's go in a more detailed manner. How are we going to make this thing become very redox? How to apply every single thing we learned previously into this application. Now, let's start. Okay? Now, I'll teach you the strategy for you to work on the application. You have so many applications. All the application, you can use the same strategy to work on it. Okay, I'll show you one by one. Number one, no matter what application it is, metal displacement, halide displacement, rusting, whatever, the first thing you must try to write a chemical equation first. Always go to write a chemical equation. After write a chemical equation, then you go to convert the chemical equation all the way to ionic equation. How you do that? We learned in our last lesson, yeah? After you convert to ionic equation, then you convert all the way to half equation. That's it. You must convert to half equation. I want to put a remarks here. In this chapter, half equation is the king. In this chapter, half equation is the king. You need half equation. If you don't know half equation in this chapter, you're going to struggle. Okay? Second thing, alright, by using the half equation that we produces, by using the half equation, you all can go to do something called redox analysis. Guys, I want you to understand my language. When I say redox analysis means apple to apple comparison. Okay? When I say redox analysis means apple to apple comparison that I taught you in the last 3 lessons. Okay? By using half equation, you can do redox analysis. You can either use the oxidation number method. You can either use oxidation number method, or you can go to use electron method. You can use either one. Okay? Oxidation number method or electron method, all these things we learned already. No worry, okay? Last one, you must give me an observation. You must give me observation. Okay? So this one we'll talk later. Okay, now let's use 2 examples for demonstration. Okay? Let me run through this. Hopefully you can understand what's happening. Let me run through 1 example first. If after the first example you still find very blurred, please ask me. Okay, we will do 2 examples in total. Now, let's start. Okay, so this one no need, this one is from the last one. Okay, now, this one I'll give you some time to copy later, don't worry on that. Okay, now let me give you an example. This is example number 1, let's do together. Okay, you are given a picture. This is a beaker. This beaker has a solution. This solution called silver nitrate solution. You guys are given a silver nitrate solution. And you guys put in a piece of metal though. This is a piece of metal. This piece of metal, I call it as a zinc strip. You put a zinc strip or a zinc ribbon. Okay? Now, can we try to work on this based on all our strategy, step by step? Okay, first of all, let's try to write our chemical equation. Let's write our chemical equation together. So how to write chemical equation? Don't memorize, but learn how it works. We have a piece of zinc. Zinc, the formula is Zn. Okay? After that, we have a solution called silver nitrate. So how we get the formula for silver nitrate? Form 4 chapter 3, all the chemical name can be converted to the formula provided you know the charge. Everyone recall back, silver the charge is Ag plus. Everyone recall back, nitrate the charge is what? NO3 -1. Okay? Form 4 chapter 3, you can change a chemical name to the formula easily when you know the charge. Okay, the charge is +1 and -1. When they have same charge, cut it off and join together. Therefore, silver nitrate, the formula is AgNO3. Are you clear with that? Alright, you must be able to change a chemical name to a formula by knowing the charge. Example, today the question say aluminium, okay, chloride. You must know the formula. Aluminium, the charge is Al3 plus, chloride is Cl minus. The charge is different to the cross. 3 go to the right, 1 come to the left. Al got 1 piece, Al. Chlorine got 3 pieces, Cl3. I give that. You must be able to change a chemical name to the chemical formula by knowing the charge. Okay? This is the Form 4 Chapter 3 thingy. Okay, now let's go on here. Okay, so guys, they only give you the left hand side, right? They don't give you what happened on the right hand side. So you must know what happening. Everyone put your eyes on here. Zinc is a metal, silver is a metal. When you have two metals appear at the same time, this is a metal displacement. I repeat, zinc is a metal, silver is a metal. When two metals appear at the same time, this is metal displacement. Okay, recall back guys, what is metal displacement? Gangster, bully concept. Zinc is a metal, silver is a metal. Zinc is higher than silver in ECS. Zinc is a more powerful gangster than the silver. Zinc will be capable to rock the nitrate. So when zinc rock the nitrate, you will get a guy called zinc nitrate. Okay? So guys, can we try to predict the formula for zinc nitrate? Not memorize, predict it. Zinc, the charge is N2 plus. Nitrate, the charge is what? NO3 -1. The charge is different to the cross. 2 goes to the right, 1 comes to the left. Zn got 1, Zn1. NO3 got 2, bracket, NO3 got 2. So this is the formula for zinc nitrate. Everyone know how you get it? Don't memorize, huh? Okay, good. Now, what happened? What else? When zinc rocked the nitrate away, now the silver got nothing left, huh? The silver, after being rocked, it got nothing left, so you just left the silver alone. I give that. Okay? Now, every time when you write chemical equation, balancing is a must. Let's do it. 1 zinc on the left, 1 zinc on the right. 1 silver on the left, 1 silver on the right. 1 NO3 on the left, 2 NO3 on the right. So you have 2 NO3, put a 2 here. When you put 2 here for the NO3, the silver accidentally become 2 as well. So the silver here also need to become 2. So what's good? So you have successfully get your chemical equation. You're not done yet, because in this particular chapter we are not happy with chemical equation. I repeat, in this particular chapter we are not happy with chemical equation. In this particular chapter we want to get half equation. So how to change chemical to half equation? We learned it from last week. Chemical equation couldn't be converted to half equation directly. So chemical equation we can convert it to become ionic equation first. You can check back the notes from last week what we have covered up. How you change chemical to ionic. List out all the charges, okay? To change chemical to ionic, list out all the charges. Come, let's do it with me. Let's start with the first fellow, zinc. Zinc is a one species element. Anything made by one species, their element don't have charge. Copy, okay? Silver is Ag plus. How many silver we have? 2. Alright. NO3, the charge is what? NO3 negative nitrate. How many nitrate we have? 2. So what's good? This is something from last week, yeah? Okay, now let's go on a little bit more. What happened to the right hand side? Right hand side zinc, what is the charge? Zn2 plus. Right hand side nitrate, what is the charge? NO3 -1. How many nitrate we have? 2. Silver is a one species element. Anything made by one species, they have no charge at all. So the silver got no charge at all, just copy backward. Yeah? Okay, now you have listed out all the charge successfully. Now what you need to do is that compare among left and right. Compare left and right hand side, you go and see any substance or any filler, they don't change at all. Yeah, it is. NO3 here and NO3 here, they doesn't change at all. Anything don't change, cut it out. So after cut out, this remainder is called ionic equation. Are you hear that? This remainder, this whole thing is ionic equation now. Okay, why? Recall back last week, what is ionic equation? Equation that got charge but no electrons. Okay, next one, can we go on further to make it become half equation? Okay, I mentioned last week guys, if you remember, how many half equation normally we have? 2. Alright, normally we have 2 half equation. It's not 1, it's not 3 or 4. We always have 2 half equation. So how you get 2 half equation here? You split them according to apple. Zinc will be pairing along with Zn2 plus. So zinc on the left will become Zn2 plus on the right. That's it. Second one, 2Ag plus all the way will become 2Ag on the right. I hope you understand this. Okay, so guys, we're not yet done. We all learned from last week. What is half equation? Half equation is the equation that got charge and electron. You already have the charge, but you don't have the electron. Okay, so you must answer 2 questions only when it comes to half equation. First question, you must start asking, how much electron I need? Number 2, where I put those electrons. Okay, the first question guys, how to know how many electrons we need? The amount of electron is decided by the charge difference. Okay, look at the total charge on the left. Total charge on the left is 0. Total charge on the right is 2 plus. 0 and 2 plus, charge differ by 2, so you need 2 electrons. Okay, you need 2 electrons. Electron should always put on the more positive side. Electron should always put on the more positive side. So you put the 2 electron on the right hand side, because right hand side is more positive. Okay? So this is something we learned from last week. You can rewind back on last week if you forgot. It's all from last week one. Okay, next one. What about this? So this further, what we can do? First and foremost, look at the number in front. This number in front is 2. This number in front is 2. When the number in front can be simplified, you must simplify. When the number in front can be simplified, you must simplify. 2 and 2 in front can cut off. Okay, you cut it off. So after cut off now, let's do the same thing. Same thing guys, half equation, you must know how many electrons you need. Okay, the amount of electron is always decided by what? Charge differences. Everyone, total charge on the left is how much? Plus 1. Total charge on the right is how many? 0. Plus 1 and 0, charge differ by 1. So when charge differ by 1 means what? We need 1 electron. Okay? So at the end of the day, we know we have 1 electron already. Where we put that 1 electron? The more positive side, which is the left hand side. So we put the electron on the left hand side here. Are you clear with that? Guys, again, if you really be observant, this is exactly what we did last week. This is what we did last week. Clear? Alright? That's why what you learned previously is so important. Those are your basics. Okay, you see guys, now we have successfully write chemical equation. We did. We have converted it to become ionic equation. We do. We have already get the half equation. We got already. Okay? So now, once we have the half equation, we can do whatever thing we want. That's why I say half equation is the key. In this chapter, you like it or not, you must know how to get half equation, which is all being taught in the last chapter, last lesson. Okay, next one. By using the half equation, let's do your redox analysis. Okay? Alright, come. Let's do this. Let us do the redox analysis. Alright? Guys, redox analysis means apple to apple comparison. The one we keep talking about. Apple to apple comparison. You remember, you can do redox analysis in 2 different methods. The first method called oxidation number method, the second one called electron. I'll do both. The first example, I will use oxidation number method. The second example, I will do electron method. Okay, I'll do both methods with you. Okay, let's use this one. This one, let's use oxidation number method. Let us use oxidation number method. Okay, let us use oxidation number method for this. Okay, how you do redox analysis? Refer to the half equation first. Guys, put your eyes on here and do it together with me. Okay, this is the half equation we wrote a moment ago. Yeah. Now, can we do this together? Let's use oxidation number method. We learned oxidation number method 2 weeks ago. 2 weeks ago. So I want everyone to participate. Let's do this together. Everyone, can we list out the oxidation number together? ON stands for oxidation number. So let's try together. Guys, for zinc, what is the oxidation number you think? 0. Why? 1 species element, right? The zinc here is a 1 species element. Anything made by 1 species is element, oxidation number 0. Okay, you can refer to the notes if you forgot the 4 rules. the 4 rules. Okay, next one. Zn2 plus, what is the oxidation number? Plus 2. Okay, because we learned before, oxidation number for the ion is exactly same as the charge. Understand? When you know Zn2 plus, the charge is 2 plus, oxidation number, copy the charge plus 2. Okay? Okay, now, you have successfully listed out the oxidation number. So how you do your apple to apple comparison? Look at here. Okay, as you can see, oxidation number of this fella, the zinc, oxidation number for zinc, 0 to plus 2, what happened? Increases. Oxidation number for zinc increases from 0 to plus 2. So you need to clearly tell people increases and from what to what. I don't want you only write oxidation number of zinc increases only. No, you must clearly specify increases from what number to what number. Your answer must be very accurate, very precise. Okay? Now, guys, we all learned before. When oxidation number of the zinc increases, what process is happening? When oxidation number is shooting up, what process? Oxidation. Okay? Oxidation, right? When oxidation number increases, the process is oxidation, guys. Whose oxidation number increases? This fella. Okay, how you write this fella? Everyone see how we name it. This fella called zinc. Zinc got no charge. Anything no charge and alone, we call this as atom. Okay, zinc got no charge and it come alone, we call it atom. If today this fella got charge, we call it zinc ion. Alright? So zinc atom, the oxidation number increases from 0 to plus 2. When oxidation number increases, zinc atom undergo oxidation. When zinc atoms undergo oxidation, zinc atom will automatically reducing agent. So this is called the redox analysis, the apple to apple comparison we learned previously. Are you okay with that? Guys, actually what you learned today is nothing new, you know. You just use everything we learned previously and put in this metal displacement, that's all. Okay? Now, let's do the second one. Let's refer to the second half equation, this one. Second half equation, Ag plus E become Ag. Same thing. Can we still use oxidation number on it? Yeah. Let's try to list out the oxidation number. Oxidation number for Ag plus is how many, guys?
1.
Plus 1. You must mention 1 and plus 1. Must mention the plus. Okay? Ag plus, the charge is plus 1. So you copy back for the oxidation number. What is the oxidation number for silver? Silver is one species element, 0. Okay? So as you all can see, silver, the oxidation number from plus 1 becomes 0. Plus 1 to 0, what happened? Decrement. Okay, decreases. So oxidation number of the silver is actually decreases. Decreases from how much to how much? Plus 1 to 0. Okay? So when the oxidation number decreases, what process is happening? Reduction. Okay guys, again, ask yourself a question. Whose decrease in oxidation number? This fella. How you call this fella? This fella is Ag plus. This fella, because got charge, the name must add a word. Ion. Okay? So Ag plus ion undergo reduction. Okay? Ag plus ion undergo reduction. Why? Because your oxidation number go down. When oxidation number go down, you undergo reduction. Okay, when you undergo reduction, what agent you are? So Ag plus ion automatic will be oxidizing agent. So, any question? So this whole thing is actually called redox analysis. Okay? This is apple to apple comparison. This is what we learned in the past 3 lessons. Are you okay with that? Alright? This is what we learned in the past 3 lessons. Not very hard. You just put every puzzles that we learned previously into here. That's it. Okay? Alright. So now you have successfully do your redox analysis. Last one. The last one I want to talk is this observation. Give me about 3 more minutes. Let me finish this. Then you jot down one shot. Guys, what is observation? Okay, technically observation should be anything related with your 5 senses. I repeat, technically observation should be something related with your 5 senses, which is anything you could see, anything you could hear, anything you could smell, anything you could taste, anything you could touch or feel. That is called observation. But in chemistry, let's be realistic. Normally, you don't go to smell the chemical because it might be toxic or poisonous. You don't taste the chemical for the same reason. It might be toxic or poisonous. You don't touch the chemical, they might be toxic, they might be corrosive. And most of the chemical, they don't produce any sound or any voice. Understand? Alright, that's why if SPM in chemistry, pop is one of it, but it's some very rare occasion. Pop sound is one of it. But in most of the cases, you don't have any sound. Okay? That's why in chemistry, whenever they ask you observation, it is very safe for you guys to assume observation is referring to what you see. Clear? Alright? Observation you can always assume is what you see. Okay? Alright guys, now how you get observation. If you want to get observation, please always go to refer to your half equation. Always refer to your half equation in order to get the observation. In this chapter, please remember, half equation is the king. Half equation is your best companion. You always use the half equation. Okay, now, guys, how to use half equation to predict the observation? How to predict? Let me show you. Come, let's try to do this. This is the last thing already. Come, let's do it. What might be our observation? What is the possible observation in this experiment? What we might see. Okay, this is what we have initially. What we might see. Come on, let's look at the half equation. Everyone follow me? Half equation. This is the first half equation. Zinc become zinc 2 plus. Zinc become zinc 2 plus. Okay? Now, I teach you two different ways. One is the common sense, another one is how you memorize later. Whenever you saw a metal become an ion, whenever you saw metal become ion, that metal dissolve. Okay? If you are with me in Form 4, Chapter 6, you learned that before. Alright? When you see a metal become ion means dissolve, and it makes perfect sense. Why? Think, metal normally appear in what form? Solid. Ion normally appear in what form? Liquid or aqueous. So you think solid all in sudden become aqueous means what? They dissolve. Understand? When a solid thingy all in sudden become liquid, it means that they dissolve. Understand? So I repeat one more time. When you want to get observation, when you know what you can see, you always refer to half equation. So if you refer to half equation, if you saw a metal, it become a metal ion. Any metal, when they become metal ion, it means that metal is dissolving. Clear? So you can write this. Okay, which metal is that? Zinc. So you can write zinc metal, or you can write zinc strip. You can write zinc strip dissolve. Sir, if I don't want to write dissolve, what else I can write? You can write anything related. If the zinc strip dissolve, you also can write the zinc strip become thinner. You also can write zinc strip become thinner. You also can write this. After you dissolve, you see part of the zinc disappearing. You also can say zinc strip is corroded. Also can. You also can say zinc strip is corroded. It's all acceptable. Are you okay with that? Alright, whenever a metal become ion means that metal is dissolving, getting lesser. Okay. Guys, let's try the second observation and the last one. What about this? Silver ion become silver. Silver ion becoming a silver. When you form a silver, when you produce a silver. So every time when you produce a metal, you will see a solid. Understand? Because we all know metal is supposed to be solid, right? Every time when you produce a metal, you will expect to see some solid thingy here. You will see some solid thingy here. Alright? So you will see some solid. Now the problem is what? What is the color? What is the color for the silver metal? So listen carefully. All metals in chemistry or in science, they are grey color. All metals in chemistry are grey color, except one. The one and only metal which is not grey color is copper. Copper is brown. Understand? Alright? So everyone must know. All metals, they are grey. Example, today your metal is iron, grey color. Today your metal is aluminium, grey color. Today your metal is sodium, grey color. Understand? Alright? All metals always grey in color. So you will expect a grey color solid is formed. You will see some grey color solid form over here. Some grey color solid deposited. Okay? That grey solid is silver. So far so good? Yeah. So I want you to write down this. Okay? So you always refer to the half equation in order to get your observation. Okay, you always refer to half equation in order to get your observation. So whenever you saw a metal all the way become ion, it means that the metal is actually dissolved. The metal is actually dissolved. Second, whenever you saw the ion is producing a metal, you will expect to see a solid is formed. You will see a solid is formed. Okay? So what is the color here? What is the color here? Depends. Okay?
Which one?
All metals, they are gray color solids. Except copper. Okay? Except copper metal. Copper metal is actually brown. Okay? Apart from that, everything is gray. So okay. So always refer to half equation in order to get your observation. Simple as that. Alright. So guys, here that's a clue. For some of you, you are with me when we are learning Form 4, Chapter 6. So if you're with me, you make a lot of sense to you because they are so similar. Okay, you can really refer back to the notes that we learned in Form 4, Chapter 6. They're almost the same. Clear? Alright? So that's it. That's why this chapter and your Form 4 Chapter 6 are very similar one. These two chapters got many half equation. Many half equation. They always ask you about observation. So okay? Alright, so I think that's it. You can jot down on this. We will do one more example together. Hopefully, after two examples, you have a better idea what is happening. Okay? So in short, guys, what we are learning today, we are learning one of the application of redox. Okay, we are learning one of the application for redox because we have learned all the basics redox for the last 3 lessons. So today we learn how to apply all the knowledge that we learned. The first application called metal displacement. So metal displacement in short called gangster bully concept. A more powerful metal brought something from the less powerful metal. This is called metal displacement. Okay, so when you're given this metal displacement thing, you must try your level best to get the half equation first. Once you get the half equation, you can use the half equation to do the redox analysis. You can use the half equation to predict your observation. That's why half equation is so important in this chapter. Take your time, jot down this, then we go on one more example. So guys, let's try to cover one more example, the second and the last one. Okay, let's look at the second example here. Okay, so for second example, we will do this. We will have a beaker, same thing. In the beaker now, I have a very famous solution in SPM, which is called copper 2 sulfate. If you do your past year question, you can see how frequent they ask this solution. I'll tell you why. On top here, we put a spoon. In chemistry, you don't call spoon though, you call spatula. Alright, you call it spatula. So the spatula now go to put in a few scoop of the powder. So now you go to add in some powder. This powder, let's say, is magnesium powder. Yeah? Okay, so this is what happening. Now, let's do the same thing as usual. Okay, guys, first and foremost, you must be able to recognize this phenomenon is a metal displacement. How you recognize? When you have a metal, you add into another solution that also got metal. This phenomenon is called metal displacement. Understand? When you solve, they add a metal to another solution that is already that also got a metal. This phenomenon called metal displacement. Understand? Okay, now, as usual, you can refer back to the strategy we learned just now. What is the first strategy? Writing a good chemical equation first. We should write a good chemical equation and slowly convert to half equation. Come, let's start with chemical equation. What we have? Magnesium powder. You don't care powder or strip or whatever. Magnesium formula forever, Mg. Okay? Second thing, you have a copper sulfate solution. So copper sulfate solution, how we get the formula? Okay, we can predict the formula of a further by knowing the charge. Copper, everyone knows, Cu2 plus. Sulfate, you should know, SO4, 2 minus. So 2 plus 2 minus, the charge is the same. Cut it off. Okay, so you get CuSO4. So this is the formula for copper sulfate. Are you good with that? Same thing, guys. They don't tell me what happened on the right. I'm supposed to know. I say just now, when you saw a metal go into a solution that got metal, this is metal displacement. Metal displacement is gangster bully concept. Magnesium is higher than copper in ECS. Magnesium is the more powerful gangster. Magnesium will rob the sulfate from the copper. So when magnesium combines with the sulfate, you will get a further called magnesium sulfate. Now, how we get formula for magnesium sulfate? Same thing, we should know the charge. Magnesium is Mg2 plus. Sulfate is SO4 2 minus. 2 plus 2 minus adjoining together MgSO4. That is magnesium sulfate. Are you okay with that? So once the magnesium take over the sulfate from the copper, now the copper got nothing left because the SO4 of the copper robbed by magnesium. Now the copper become alone. Got it? Alright? Now, double check, triple check, your equation must be balanced. So this equation is already balanced. So you don't need to add any number. Okay? Second thing, guys, by me saying that in this chapter, chemical equation is not that useful, understand? So I think half equation is a bit better. So how to change chemical equation to half equation? You must get them the ionic equation first. How you do that? We learned from the last lesson. Chemical equation can become ionic by listing out the charge. Magnesium on the left hand side is not Mg2 plus because anything made by one species, they are element don't have charge, Mg. Understand? Copper is Cu2 plus, SO4 is SO4 2 minus. Settle the left. Right hand side, the magnesium here is Mg2 plus. Right hand side, the SO4 here is SO4 2 minus. The copper here is one species element, no charge. Okay? Compare among the left and the right. When you compare left and right, you realize that the SO4 doesn't change. SO4 on the left is 2 minus, on the right still 2 minus. It doesn't change at all. Anything doesn't change, cut it off. Okay? So upon cutting, this final answer is the ionic equation already. Okay? Lastly, we are not satisfied with ionic equation. We are not satisfied with ionic equation. We are looking for half equation. Remember, we always have two half equation. We always have two half equations. Okay, how you get half equations? Split according to apple. The first apple, magnesium on the left, pair with magnesium 2 plus on the right. Let's go. Mg become Mg 2 plus. Second apple, Cu2 plus on the left, pairing with Cu on the right. So far so good? Same thing, half equation forever need electron. Electron decided by what? Charge difference. Left hand side total charge 0, right hand side total charge plus 2, charge differ by 2. 2 electron is needed. Electron should put on the more positive side, which is the right hand side. So far so good? Same thing here. Total charge on the left is 2 plus, total charge on the right is 0, charge differ by 2. 2 electron is required. Electron put on the more positive left hand side. Understand? So we have successfully get the half equation. And by me saying that, in this chapter, once you get the half equation, you can be the king. You can use the half equation to do all the important thinking. Understand? Okay, now let's do it. Let's use our half equation to do redox analysis. Let's use our half equation to do your redox analysis. So remember guys, for those who don't understand what is redox analysis, you can refer back to the past 2 to 3 lessons. Redox analysis means apple to apple comparison. Okay? And there are two important methods you can use. The first method is oxidation number method, which we use already. Now we change a bit. What if this question we go to use electron method? What if this question we use electron method to do our redox analysis? Okay? So guys, electron method is the method we learned from last week, the last lesson. Come on. No matter oxidation number or electron method, don't worry. Always refer to your half equation. So let's look at half equation. Mg become Mg2 plus coupled with 2E. Okay guys, come on, I need your attention here. When you want to use electron method, I mentioned last week. When you want to use electron method, you must know you are donating or receiving electron, right? And I say last week, to do electron method, you must be very sensitive with what? Location of the electron. So everyone put your eyes on here. In this particular case, the electron is seen on the right. Okay guys, we learned from last week. When electron appearing on the right, is donate or receive? Electron appearing on the right hand side, donate or receive? Donate. Electron on the right is donate, on the left is receive. Understand? So when you saw electron on the right means donate, guys. Who's the donor? This fella. This fella throw the electron. This fella throw the electron. So this fella donate. So how you write this fella, guys? How you call this fella? This fella formula is Mg. Copy back. This fella, the name is called Mg. Okay guys, how we name it? This fella got no charge, and it come alone. Anything no charge and come alone, the name should end with what? Atom. Alright? So magnesium atom donate how many? 2 electrons. So your magnesium atom donate 2 electrons. That's it. So when you donate electron, everyone can check from electron perspective, from electron standpoint. Donating electron stand for oxidation. So magnesium atom donate electrons, so magnesium atom undergo oxidation. So when magnesium atom undergo oxidation, magnesium atom will serve as reducing agent. Yeah? So this is how the whole thing works. Okay? Guys, what I'm trying to tell you is that it's nothing new, you know. All these things are something you learned before. We just apply it. That's why we call it application. Okay? Alright, good. Next one, Okay, the second apple to apple comparison is this. Let's go for the second one. The second one is here. Cu2 plus 2E become Cu. Come on, let's finish it strong. Okay, in this case, same thing. I want to use electron method. Electron method, we must be very sensitive with the location for electron. I saw the electron appear on the left. Electron on the left means receive. Okay, who is the recipient? This fella. How you call this fella? This fella is Cu2 plus. Copy Cu2 plus. Very good. This fella got charged, you put the word ion. Very good. Cu2 plus ion. Electron on the left means receive. So you write the word receive. Okay, how many electrons? 2. So you receive 2 electrons. So when you're receiving electron, the process happening is reduction. So Cu2 plus ion receive electron, therefore Cu2 plus ion undergo reduction. When you undergo reduction, the Cu2 plus ion, when you undergo reduction, you are oxidizing agent. I don't think it's that hard. Okay? It's everything we learned before. I keep telling you all these things because I want to emphasize all these things is something we learned for the past 3 weeks. Understand? These are all the basics, all the apple to apple comparison we just put together. Okay? That's why if you struggle for this, please look back all the previous notes, all the previous last 3 lessons. Those are the basics. Are you getting that? Okay, now, come, let's finish it. After we get the redox analysis, we also can use the half equation to get observation. Come on, guys, let's do this and finish it up. Okay, what is the observation? What we can see? By me saying that, whenever you want to get observation, you must refer to half equation. When you want observation, you can refer to half equation. Come on, let's refer to the half equation. Mg become Mg2 plus 2E. By me saying that, when a metal become ion, what is happening? Dissolve, right? So in this case, you can write magnesium powder dissolve. So some people say, sir, if I don't want to write powder, can or cannot? Can I only write the word magnesium dissolve? Okay, no problem. Okay? Okay. But guys, be careful, That's why I say this. When metal become ion, the best possible words you use is dissolve. You cannot say thinner. Why? When you have powder, I don't think powder can become thinner. Are you with that? So you can only use thinner when this magnesium give you in a piece. Either give you a strip, a piece of magnesium, then you can write thinner. But if the magnesium come in powder form, cannot. Guys, don't make your life hard. So that's why no matter strip or whatever, I always do this. When I saw a metal become ion, I will always write dissolve. I don't need to go for thinner, smaller, no need one. Here, when a metal become ion, you just write dissolve. End of story. Easy. Here, why? Dissolve is applicable when you are powder. Dissolve also applicable even you are a strip. Are you okay with that? So that's it. So when you saw a metal become ion in a half equation, it means that metal is dissolving. So far, okay? Alright, second observation. Second observation, put your eyes on here. Cu2 plus 2E becomes Cu. Cu2 plus 2E becomes Cu. Guys, you are forming or producing a copper. So when you produce a copper is a metal, you expect to see what? A solid, right? You will see a solid because metal appear as a solid. Now the important thing, what color is copper? Brown. Okay? Remember, all the pure metals are gray except copper. Copper is brown. So you expect to see this. A brown color solid is formed. You will see some brown color solid deposited. So after a while, you can see some brown color solid deposit over here. Those are copper. Understand? Okay, the last one, which is very important. Allow me to put 2 star here. I'll tell you why. Okay guys, listen carefully. Okay, I'll put 2 star. This is very important. Okay. In SPM, they always love to ask you copper 2 sulfate solution. In SPM, they always love to ask you copper 2 sulfate solution. The reason is this. Any solution that inside got Cu2 plus, any solution that got Cu2 plus inside, they will give you a very wonderful blue color. Okay, I repeat. Any solution that got Cu2 plus, they will give you a blue color. Like, some of you will confuse already. Some of you will say, sir, I thought you said a moment ago copper is brown. Don't confuse, okay? So please be careful, don't confuse this. Do not ever mess up these two fella. The first fella is copper, the second fella is copper 2 plus. They are very different. Copper is a brown color thing. Cu2 plus is a blue color substance. They are a bit different. Secondly, copper is a metal, so it's a brown color solid. Cu2 plus is the ion, is a blue color solution. So please be very careful. Okay? SPM always love to ask you copper 2 sulfate solution because they want you to tell them what happened to the blue color. Okay? Let me repeat. Any solution got Cu2 plus, the original color is blue. So they want to ask you what happened to the blue color. Your blue color got 3 possibilities. Don't memorize. You can use the common sense of teach you how. Okay? See, the blue color solution have 3 possibilities. Number 1, it might got paler, it might got paler, or it might got darker. Or the blue color doesn't change at all. Clear? You have 3 possibilities. Your blue color might got paler, your blue color might got darker, or your blue color remain unchanged. Now, how on earth you know what happened to blue color and you don't memorize it? You don't memorize it. You just need to answer a simple concept, guys. Who gave the blue color? Cu2 plus. So you just need to understand, in this experiment, what happened to the amount of the Cu2 plus? If the Cu2 plus getting more and more, you become darker. If the Cu2 plus getting lesser, you become paler. If the Cu2 plus amount doesn't change, so the blue color remains. So how to know the Cu2 plus become what color? Look at your best companion in this chapter. What is it? Half equation. Look at the half equation. This half equation was Cu2 plus, right? Follow me, Cu2 plus 2E becomes Cu. Cu2 plus 2E becomes Cu. Cu2 plus now is converted becomes Cu. Cu2 plus convert becomes Cu. When Cu2 plus becomes something else, take a wild guess. Cu2 plus is getting more or getting less now? Getting lesser or not? Because Cu2 plus becomes something else now. So Cu2 plus getting lesser. So when Cu2 plus getting lesser, what happened to become to the blue color? Paler. Understand? That's it. So your blue color will become paler. Your blue color of the solution will become paler. That's it. So you don't need to purposely memorize one. You just need to check your half equation, and from the half equation you predict whether you get more Cu2 plus or you get less Cu2 plus. From there you can predict whether the blue color got paler or darker. Understand? You got me? It's not very hard. Okay, so SPM love to ask you the question got copper solution because they want to talk about the blue color. Okay, and the worst answer you can ever write is this. A lot of people write this very bad answer. They write this: Cu2 plus is blue, Cu is brown. So they write blue color become brown. Cannot. Why? The blue color is referred to who? The solution, right? The brown color refers to the solid. One is solution, one is solid. They are two different things. You cannot talk together one. Understand? So you cannot write blue become brown. That's wrong. So far, okay. So this is a very popular question you should know in your paper. Understand? Okay, finish. That's all about metal displacement. Not very hard one. Very easy one, okay?
Can I get the answers for
Okay. No problem.
Alright. So guys, let me show you one questions. Okay, this is a sample questions how they can ask you metal displacement in your examination. Come, let's do this together. So you can see there is a copper strip and there is a silver nitrate solution. Okay guys, remember when you saw a metal go into a solution that also got metal, that is metal displacement. Okay, first one. What is meant by redox reaction? We learned this 3 weeks ago when we first started. So what is redox? Redox means that there is reduction, there is oxidation. These two processes happen at the same time. When you have oxidation process, when you have reduction process, they happen at the same time. That is called redox. So okay? Alright, you learned this when we first started of this chapter. Second thing, can we write ionic equation for this reaction? Okay, everyone recall back. What is ionic equation? The equation that got charge but don't have electrons. So how to do it? I think we can start with a chemical equation first. So let's write a chemical equation. Copper is Cu. Silver nitrate, let's predict silver is Ag plus. Nitrate is NO3, -1. +1 and -1 cut off the charge. So you get AgNO3. That is the formula for your silver nitrate. So copper and silver. Copper is higher than silver in ECS. Copper is the more powerful gangster. Copper will rob and take the nitrate away. So when copper takes the nitrate away, you are getting a fella called copper 2 nitrate. So I know I get copper 2 nitrate. Can we predict the formula for copper 2 nitrate? I think so. Copper 2 formula is Cu2 plus, nitrate is NO3, -1. Their charge are different, cross method. 2 go to the right, 1 come to the left. Cu got 1, okay? NO3 got 2. So you put a bracket, the NO3 total got 2, okay? Alright, don't forget, after the copper robbed the nitrate, now the silver got nothing left. The silver now become alone, Ag. Okay, because the NO3 taken by the Cu already. Okay, when you write chemical equation, balancing is a must. So I do faster, you put a 2 here, you put a 2 here. I hope everyone know why. So is this the final answer we submit? No, this is a chemical equation. We are looking upon ionic. So how to change chemical to ionic? List out the charges. Copper is one species element, no charge. Silver is Ag plus. You have 2 silver on here, put 2. Nitrate, the charge is NO3 negative. You have 2 nitrate here, put a 2 here. Go to right hand side. Right hand side copper, the charge is Cu, 2 plus. Right hand side, the nitrate is NO3 negative. How many nitrate we have, guys? There's a 2 at the back here, so we have 2 nitrate, So the silver here is one species element, no charge. Compare among left and right, and you realize the NO3 doesn't change at all. Cut it out. So this remaining answer is your ionic equation. Clear? That's how we get ionic equation. Learn how to get it, don't memorize. Okay? Learn how to get your ionic equation. Alright, so we have get our ionic equations already. Now let's move on a bit more. We have a few short questions. Let's finish it. Now the question asks us, which element undergo reduction? Which element undergo reduction? Explain your answer by using electron transfer. So when I say electron transfer means what? You have to use electron method. So when you want to use electron method, we must have half equation, right or not? Because ionic equation don't have electron at all. I can't even see the electron from here. Okay? So I think we should split the whole thing, become the half equation. Let's try. Okay, Cu becomes Cu2 plus. Cu becomes Cu2 plus. So you plus 2 electron here. I hope everyone know why. Okay, next one. 2Ag plus become 2Ag. Remember, the number in front is the same. You can cut it off and simplify. You cut off the number. So Ag plus and Ag, the charge differ by 1. Put 1 electron on the more positive side. So I produces these two half equation. Okay. Now, which half equation to be used? Now you see that. Which element undergo reduction? Explain your answer by using electron method. Let's brainstorm together. If you want to undergo reduction, from electron perspective, reduction is what? Receive electron. So when you want to receive electron, the electron should be found on the left. So who have the left? This fella. Understand? So this fella. So I write it. Ag plus E become Ag. So I saw the electron on the left means this case electron received by who? This fella. This fella, what is the name? Ag plus got charge called ion. Silver ion. Or if you want to write in name also can, you can write this. Silver ion. Silver ion undergo reduction. Why? Why it undergo reduction? Because your silver ion accept, or you can write the word gain. You can write the word receive electron. How much? 1. So when you receive electron, you undergo reduction process. So far, okay? Not very hard. It's something we learned early on today, Okay, next one. Tell me 2 observations in this experiment. Observation, always good to refer to your half equation. Your half equation number 1, Cu becomes Cu2 plus. Cu becomes Cu2 plus. When metal becomes ion means dissolve. So you will see copper metal, or copper strip dissolve. Second one, when Ag plus become Ag plus become Ag, you are forming a silver. When you form a metal, you get solid. Silver is normal metal. You should see gray. So you will get gray color solid is formed. Yeah? So you get 2 observations easily. Okay, let's do the final touch. What is the color change of the solution? So guys, to know color change, you must understand what is the original color for solution. Listen carefully. Listen carefully. Originally, your solution got silver nitrate. Silver nitrate is Ag plus. Ag plus got color or not? No color at all. Nitrate got color or not? No color at all. So originally, your solution got no color one. Remember, which ion got color? Those ion got color is those famous one you learned in Form 4 Chapter 7. Cu2 plus give you a very nice blue color. Fe2 plus give you a very nice green color. Fe3 plus give you a brown color. You learn this in your Form 4. These 3 ion got color. Apart from that, most of the ion got no color. Okay? So initially, silver nitrate don't have these 3. Okay, so initially the color is colorless. Then what happened in the end? As you can see, Cu becomes Cu2 plus. When Cu becomes Cu2 plus, now all of a sudden, inside here got Cu2 plus already. When you got Cu2 plus, now the color should become what? Blue. Okay? So you will see the color change from colorless in the first place, all the way become blue. So that is the color change. Are you okay with that? Alright? You cannot say that blue color become darker. Why? Some people say, sir, I thought Cu becomes Cu2 plus, we are getting more and more Cu2 plus should be more blue. No! Because your original color is not blue. Originally, you don't have Cu2 plus at all, Initially, silver nitrate don't have Cu2 plus at all, So originally, you have no blue color. So you cannot write blue color become darker. Clear? So you have to write colorless solution become blue. Okay, so I think that's it. This is what you need to know for your metal displacement, your first application. So once you understand this, the remaining application will be a bit easier for you. Okay, alright.